All right, and we are on our second part, still with Matthew.
Hey there.
Now we will continue discussion on the embedded devices versus the off-the-shelf, meaning that some are custom made, some are just bought for some specific need. And what we're going to do is I will just offer you some specific examples, and I will be interested to see what will be your choice, either to buy something from the shelf or to deploy something custom and make it from ground, right?
Yeah.
So before we start this example, here we have few examples of the thing that's, so the specific custom devices that Field Cloud is doing. We have some enclosures, some hardware based on either Raspberry or other microcontrollers. And I don't know if you want to tell us a little bit about that before we start.
Yeah, absolutely. And so I'm just showing you that we've got another camera working to have a secondary view. But Mark, no, great question. And I do think that I also want to frame it a little bit differently. This isn't about necessarily custom devices versus off-the-shelf devices. It's really when does it become useful and necessary to design a product or a specific solution because there is no other available commercial off-the-shelf product.
Oh, wait, do you think that for standard, we should start with off-the-shelf existing solutions before going into custom design?
Well, look, there was a time when nothing existed off the shelf,
okay,
right? We all take, certain PC form factors for granted. And in fact, some of those PC form factors for personal computers are already outdated and are less common, in real life.
Yeah.
If you think about, the XT motherboard, the AT motherboard, the ATX motherboard, the ITX motherboard, Nano ITX, and then you've got more recent form factors like NUC, the next unit of computing, which Intel has kind of discontinued. There are some standard, let's say there are some standard ways, right, that emerge or sometimes are deliberately put in place in order to create commodity off-the-shelf products, right? And I think the key word there is commodity.
Commodity,
right?
yeah, because
it's commodity.
You use it for an experience or something that you need to solve, right? To solve a problem.
Well, yeah, not only that, it's just that, you end up taking something which, again, is quite specific, but you want it to be generic and, interchangeable as well. It's like, for example, if you think about, again, coming back to the restaurant example of potatoes,
again,
French fries, and the experience of eating those French fries, right? So, fundamentally, potatoes are potatoes, okay? And if you apply a commodity approach to potatoes, you don't care what type of potato, what variety, or what cultivar of potatoes you're actually using. Okay, and again, this kind of misses the point of making great French fries because not all potato varieties are actually suitable for making French fries, right? If you're making, for example, pomme dauphinoise, or if you're making tartiflette, or if you're making fries, right, you are going to use different types of potatoes. And that is a distinguishing feature. So while potatoes generally might be a commodity, all right, you are going to pay attention to, hey, within this commodity class, there are some specific, versions or variants, right, that have, either great taste, a great texture. And this is true when it comes to electronic products. Okay. And by treating a class of products as identical and as almost totally interchangeable, that's where you'll end up with either quality or I would say other issues,
or mismatch with the
and
final product.
And a mismatch between the outcome and the ingredient that's used to produce the outcome.
I see. So that's a good metaphor with the potato, because you can see, like, everyone can easily see the process, making fries and or making a tartiflette so if we do that exercise, let's consider we are the ones who will choose the potato. Let's say, buyers from McDonald's, without citing that brand. And instead of potato, we want to buy a technology. I want to give you, first one example of, let's say I'm in agriculture, right? I want to buy a technology which will send to me the level of humidity or some specific molecule that I need to monitor on my field. In those kind of environments, and that will be one example to talk about, the external factors. In those kind of environments, do you think it's more useful to buy some standard equipments, which some of them exist, or do you see that it's still useful to redo the design and make something specific to that need?
Okay, so there's two ways of considering this, and I really believe that both are valid, depending on a number of factors, right? So number one, right, is, today, 2024, there already is a very wide variety of mature products that are mass produced at scale, where the unit costs are clear, and the pricing is also very affordable. And again, a lot of that comes down to economies of scale. All right. So again, it's completely legitimate to go and buy an off-the-shelf sensor device. And really, the only criteria you're going to apply is, what kind of actual sensor measures temperature and humidity. What is my tolerance? What is my degree of accuracy? So there's that. Then you might look at, how are the measurements turned into data? What's the format of the data? What's the degree of precision in the actual, process variable that's and then you look at the connectivity and is this particular network connection going to work in my location? Okay.
Right.
And so, those evaluation criteria are quite clear. I think back, 10 years ago in the whole IoT space, these things were not mature at all. And it really was a frontier moment where we were trying to sort of figure out, we almost have to go back to the fundamentals because none of this exists yet.
All right.
Okay.
So do you, I will go the opposite side and say, is it, let's say I'm a company that manufactures only custom-made sensor for agriculture. I don't know, for maize crops, or am I doomed to failure because now there are some standard devices that are going I don't know, regular?
Well, it depends on your worldview, and this comes back to the second point I wanted to make, right? Which is where you may want to design and basically create a solution set or a product set that is specific to that requirement. And you know, I wouldn't say that you're doomed to failure unless you are trying to compete in a market that is already mature and saturated. Okay, so you have to bring something very different and very novel to the table.
Than what is exists already. Okay.
Yeah, and which again, has a more powerful reason, right? Of, hey, use this because I get this different results compared to what the current generation products are able to deliver. But one reason why it is worth considering designing or working with a partner that is able to again go through a design process, custom engineer, and produce very specific hardware, is that it's a great learning opportunity.
Yeah, for sure.
When we work in a very abstracted world, okay, and this is true of modern society today, is we live in a world of abstractions.
Yeah, we have completely forgotten that everything, even the internet, is based on some infrastructure. And we tend to forget about that.
well, that's right. That's right. And, rewind, 30 years and, you really did need to know a lot of fundamental telecommunications technologies in order to build and implement an internet network. As we look at the computing space, right, and the different generations from very large, very custom manufactured computers, right? So mainframe systems and even mini computers back in the 60s and 70s, right, were built to order. Okay, and some of the manufacturers had specific departments for custom engineering.
Nice. Okay.
Some of the very original control systems I worked with in ESCOM in the early 1990s, which were installed in the 1970s using 1970s computer technology, right? Parts of the hardware set were actually built by Digital Equipment Corporation's custom engineering department.
Yeah, because it didn't exist before, but nowadays it will be like your regular RTU that you can buy from a catalog, but at the beginning it was all custom made, right?
Well, yeah, and I mean, if you look at some of the protocols and some of the actual, and what's really wild though was that my mentor in when I was really young at the beginning of my career in ESCOM, a gentleman called BD Nell, Barent David Nell, right? And so BD was big into electronics himself, okay? And he, as an end user customer, right? So as a principal technician, senior technician working in the telecontrol department, right? Wow. He actually designed himself a little electronic add-on box, all right, which became known as the BD box, okay, that was used to help decode and troubleshoot communication between RTUs and the master station. So basically, there was some data that was encoded using binary coded decimal.
Yep.
And basically, this little box was a way of providing some troubleshooting display to look at whether there was any issues in the BCD encoding, right? And
nice.
Back in those days when we had discrete logic and it was transistor, the integrated circuits were a lot simpler, right? You were a lot closer to the low-level logic, right? And so when you were studying, you weren't studying a highly abstracted, concept.
Yeah.
You really were getting into the fundamentals. And so, you had to connect an oscilloscope to look at traces to look for logic errors, right? It's very
Now-
rare today that in a factory automation setting that we take
Yeah.
out a logic probe or an oscilloscope on the factory floor.
The maximum you will do is if it's TCP, you will just plug a Wireshark, or if it's serial, at least maybe some PuTTY interface for serial monitoring, but that's it.
Completely.
But I
completely
did
agree,
it
right?
with the oscilloscope, and I mean it's important to know and to it's as you said, it's a learning experience for a person, and if it doesn't exist, the solution definitely it's worth
Right.
to implement it from scratch. Let's switch to that camera maybe,
Yeah.
and I will just tell you about another example. Let's say, and I had that with my clients this discussion. Let's say I'm a company which is very high on Arduino, for instance. Like
Yeah.
I have 5 engineers who are really experienced on Arduino. So the only thing they know to do is to implement all the projects from scratch, like with an Arduino program, even though Arduino can be considered already high level, but still they do their board, electronic printing, they will print it somewhere and then integrate the whole thing. And I have in front of me a factory that needs, I don't know, to monitor some, let's say, like quality control, so camera device that is linked to some serial interface, and they do the processing of that image. Is it worth continuing that route of Arduino because I have my 5 engineers who are experienced in Arduino, or do you think it's worthwhile going to the catalogs, for instance, for camera providers, and buying something that has already that function embedded in the device?
Hey, you know what? Without knowing more about the actual customers' kind of values, principles, culture, and their strategy, right? It's a very difficult question to answer. The fact that there's already an in-house team of like 5 Arduino specialists who have come from this renaissance in lower level electronics and embedded systems is already a good sign, because it means that there's an acknowledgement that we do care about the underlying things that are abstracted.
Layers.
So that's good. And as we might say in French, c'est double tranchant, right? It's a double-edged sword, because there's a advantage and there's a disadvantage here, right? The advantage is that you will be able to, again, apply technical competencies and skills to engineer something that is fit for purpose, right? Or at least what you would what you think should be fit for purpose.
Yes.
Okay, right? But if one doesn't at some point kind of open up a little bit and consider what's happening around you, right? So this is all about the principle of stepping outside your box, right? And kind of exploring what the rest of the industry or the basically the rest of the world has on offer, right? Okay, and this is also comes back to what we might refer to as the sort of the not invented here syndrome, right? So companies that are again very sharp on having in-house engineering talent, that probably design their own complex products, tend to build up a certain pride in their quality of engineering, which is great. I mean, this is something to be celebrated. However, all right, it gives rise to a not invented here syndrome. It's like our way is the only way. Okay. And so you end up becoming closed off to saying, oh, actually, hold on a second. See what these other people are doing. You know what? Maybe we can learn from them. Maybe we can share some insights. And I think one has to be mindful, particularly if you're in engineering management or in an executive role in this kind of companies, to be mindful of that. And
Yeah, so it doesn't become from a syndrome a total big disease, right?
yeah, and it can,
Okay, okay.
and you can see that in some engineering companies, or even some product manufacturers, where they're still using 25-year-old, 30-year-old philosophy for designing and specifying embedded electronics. Okay.
Okay. I have a third example for you.
Sure.
So I think here, if we look
Yeah,
that way, there will be someone there who would know exactly what I'm going to talk about. Let's say I'm in a geographical area where the expertise, so the skills are not there. I mean, we have few engineers, or we no longer have the engineers that we used to have. You can think of places like countryside of France, where engineers don't want to go. You can think of like industrializing countries, like in the southern America or Africa, or like some places. How do you go about building, I don't know, manufacturing with very few skills available? Do you use some custom functions, so you have to train your people and it will take maybe some time, or do you buy some off-the-shelf solutions?
So there is a real wow. There's so many layers to that question. There's a key word here, and that key word is capacity building. All right. So as part of any strategy to, again, enlarge a footprint or to develop, again, an industry in a particular geographic location, and whether this is in line with, for example, rural development in a post-industrial, market like France, whether it's to do with, structural development for, economic upliftment across, pretty much all of Africa. There is a requirement to, again, acquire skills, right? So there's the academic and educational part to it. But we don't just talk about education in isolation. It's about capacity building. So capacity building really means a lot more than just simply learning and acquiring knowledge, right? Capacity means that you are actually able to practice, and you're also able, in terms of one's means or one's earning power, right, to be able to participate.
Oh, right.
Okay. And so any strategy that's involved in sort of like building out a, let's say, sort of industrializing or, again, developing, really needs to start. So there's absolutely an education part to it. There's an apprenticeship part to it. So this is all about sort of learning, as an apprentice from masters. We know that that sometimes you will need to import the master from another place. Okay, you may need to import teachers. Okay. There's some great examples of where this has worked well. There's also tons of counter examples where it has failed spectacularly. Okay. One of my one of the things that I'm very mindful of today, when you look at certain countries in Africa that are really pushing capacity building, okay, is that, and this is coming back to your point about build versus buy, right?
Exactly.
Is the how can I say? So the kind of the compromises or the sort of the narrow thinking behind the capacity building, which is we need to have people who can learn, who can basically learn the fundamentals, apply the fundamentals, do innovation projects. There's very often a lot of sponsorship and grant money that goes into this, which allows some lowest common denominator building blocks like Arduinos and Raspberry Pis to go to these countries, right?
Yeah.
But unfortunately, because there isn't an industrial culture or a technology culture in place with mature manufacturing, factories, etc., right? Kids really are only getting what they have in the classroom and what they're playing with as they tinker with these building blocks, right?
Yeah.
They don't see the real thing. They don't also get to see legacy technologies or old installations. There's only a couple of outlier countries in Africa that have sufficient industrial footprint where you can actually get experience in that.
Yeah.
Okay. And sadly, my home country, South Africa, a lot of that kind of industrial base has either been scaled back or is dysfunctional because there's power cuts on a daily basis in the country, right? And kids don't want to do that, right? They'd much rather play with their smartphone, right? And watch YouTube videos. But you've got to expose people into real, proper installations. And in order to do that, you're going to have to jumpstart that by importing some skilled resources and having proper apprenticeship schemes. Okay. There's no shame in doing that.
Okay. So that's when we are lacking the skills, and we want to build manufacturing. You need to take care of that capacity planning, right? Alongside, buying, importing some technology, you need to build also that experience. Okay. And another example, you see, there is, let's say, I think about like a sector like textile industry, right? They will have, I don't know, some boards which are custom made for jacquard, weavers.
Yeah.
Or you will have some specific devices that can do only that specific type of printing for fabric, you know.
Yeah.
These kind of industries, and I take the example of textile, but I think there are other sectors like this where all the devices are custom made.
Cool.
What do you think about that? Is it a good thing for that sector, or is it something that draws, for instance, the textile industry lagging behind the others?
Hey, if it's part of your competitive advantage, great, right? If and that maybe that's a sieve or a lens to kind of like evaluate things. It's like, okay, is this part of our competitive advantage, right? And one needs to continually go back and ask that question on an ongoing basis, right? Because the reason why you may have chosen to develop custom hardware or specific hardware for that particular part of the process, the reasons the circumstances that led to those reasons may have changed. And I think that's important because, even today, right, I'm kind of mindful that, when FieldCloud started building our very first gateways in 2011, so we launched this kind of like crazy project to see, could we build a gateway, and basically that's the box. It's called the NS box, right?
Okay.
And in fact, this is the actual product. And this larger box here, right, was our very first kind of version 0 prototype. And by the way, this used an off-the-shelf embedded single board computer made by an American company called Technologic Systems. It has two 2.5-inch solid-state hard drives in it that are connected using SATA, and there's a whole bunch of crazy cabling. But that was a minimum viable product. And we actually went out in 2011 to Malaysia, and fitted this, retrofitted an outdoor enclosure, and had that installed on an offshore platform. And the reason why is because there was a requirement to do data acquisition, normalization, and obviously communication over satellite
Yeah.
with a very severe power constraint. So an industrial PC wasn't appropriate.
Because it would draw too much power.
Right. And then a truly embedded kind of gateway device, like a programmable automation controller, wasn't appropriate because it didn't have the processing power and nor did it have the storage.
Yeah,
Right.
and neither the connectivity also, because the pack can connect maybe to one or two channels, but not to all of these. So.
Exactly.
Okay.
Exactly.
And
So
you said, sorry, you are mindful of when you design those first gateways compared to nowadays. What's the thing that you try to control or to avoid
well, we try
in terms
to
of
avoid
technology, or you know?
Well, I'd say we'd sort of try to avoid being too too kind of radical in the sort of like the kind of the conception part, right? So when we're looking at some very a wish list, right? I think calling it requirements is a bit gives it too much justice, right? Most of the time, I would say a typical client is going to have a wish list,
Yeah.
and is going to have a very difficult time to translate that into a detailed set of requirements
Exactly.
and a specification. So as the French would refer to it, a cahier de charge, right? So a cahier de charge, or a requirement spec, okay, does actually require a good amount of expertise, and in particular cross-functional or interdisciplinary expertise in order to express the requirements properly. Okay. But you know what? It's fine to start with a wish list. Because as long as you're going back to this key question of like, who do I want my customers to become, right? And think about the, again, the outcomes, the results for your own customers, right? And then what may be required to again produce that outcome and deliver that result. That's going to again allow you to at least have a high level wish list, right? And then it's good to come in and co-create, right?
Yeah.
Bring in experts, bring in external people who've had a lot of experience in doing things the hard way, right? And we'll figure it out together, which means that we could then create a very powerful requirement spec.
Sure.
And also avoid spending time writing crazy documents like a requirement spec, and actually go about testing and experimenting to go from an idea to a mock-up to a bench prototype to an actual initial kind of working prototype, a field prototype, and then take the field prototype and put it into the into some kind of limited production, a pre-series.
Just to test,
Okay.
Yeah, that's nice. I mean, it gives some ideas, of from what point it's useful to come back to the basics, right? To the principle of custom design, because even though in the end we will buy like 80% of the shell, 20% custom, it's already good, as you said, to request for the expertise of people like Phil Cloud or others who have the experience of integrated several type of technologies, even starting from scratch, because they will be able to guide you from like which way you should route your design and your specification.
Yeah.
I wanted to maybe slowly go to the end of the discussion, but one thing, maybe we can discuss also. So that was the technological part of the discussion, right? So the buy or build, the custom made or off the shelf.
Yes.
And you gave us some hints, but there is another interesting topic to discuss around the cultural aspect of those technological projects, which has to do with the way our society is done, the psychological aspect of dealing with humans. And I know it's a whole other topic, but this will be the next discussion. And we have that talking about expertise. We have that community of well-known experts and all the industry 4.0 people, especially here in France, we are pretty much interconnected. So what we will advise you to do maybe is to, get involved in that discussion between all members of that community. And I know you are doing something quite good currently for the community.
Yeah.
Can you tell a bit about that?
Well, yeah, and I mean, I think we should really thank our dear friend Rija, who just finished up a 90-day LinkedIn post challenge to produce content on a daily basis. And Rija, you set the bar. You really raised the standard for this, and challenge accepted. And I'm running right now a 90-day challenge of my own, which is to post content daily on LinkedIn. My twist to this is that I'm going to post original video every day. And that's a tough one, to actually record a short video.
Great challenge.
On a daily basis and publish that same video to LinkedIn. But it's a great way. This long form video, we're having a chat. It's very ad-libbed. We've prepared, but we're also experimenting.
It's nice. I mean,
posting that, sort of daily kind of like, few minute long video, really kind of like you try to condense, something like succinct into short space of time. Anyway.
I've been about that challenge and the format that you are choosing to have in the next 90 days. I've already watched your content for the first 3 days. And what I can tell is, even if you are already an expert, or if you don't know at all anything about industry, especially like the cultural aspect of it, it's nice to put your knowledge or not of that industry in the mirror of what Matthew will be throwing as content. Because I did the exercise for the first 3 days, and I can tell you it's interesting, like how it will challenge your point of view. And maybe it will spark some innovation in the way you are working in the daily basis in manufacturing.
Yeah.
And it's always important, to take few minutes. It's just 4 or 5 minutes long, your videos, few minutes every day to learn. I can tell you will learn more from those videos, which are short format, instead of, waiting, putting 2 weeks in a row, going to a remote training. So it's a nice short formats, a learning experience that I enjoy.
Yeah, very cool. No, thank you, Mark. I really appreciate that, man. That's such a great way of kind of explaining the kind of purpose behind this. I also think that very often we kind of get quite sort of set in our particular lane. Okay. How do we say it in French? Tête sur guidon, right?
La tête dans le guidon.
La tête dans le guidon,
nose
right?
to the grindstone.
Yeah, so nose to the grindstone, and very much in your swim lane, okay? And when you are really, focused in your discipline, okay? And that's great, definitely master your discipline, okay? And at the same time, every now and then, come up for some air and see the world around you, and look at things kind of like a bit more zoomed out, and consider the broader societal implications. And I think if we are more mindful of that, particularly as engineers, right, about how does what we intend to do, how does that impact society, right? Because being mindful of that is going to help us shape the world that we want to live in, right? And so you've got to kind of ask yourself, the question is like, what world do I want to live in, right? Do we want to live in a world where there is, a marginalized underclass, right, and a very small group of elite, highly concentrated owners of mega corporations, where manufacturing has become so consolidated because there's this infinite quest to build the ultimate economy of scale, right? you know, and
That's one side.
and where you know, industrial projects require or seem to require, right, larger and larger scale and more prestige, right? You know, we're very familiar with this concept known as a gigafactory, right? A giga usine in French. And to be honest, I'm like, man, I think I get it, right? It's because, you know, there's a hedge fund manager or some large finance, you know, financial fund, right, that is looking to again consolidate, and for those that work the numbers, it would be easier if everything was consolidated, right?
Sure.
Because a lot of this has got to do with structural financing, right? Very long-term plays where again, you want to kind of group money, right? You know, back in the old days of the 20th century, right, a lot of this was done with pension funds, right? Where you know, as a worker, you would be paying into a pension pot, and that pension pot would then be invested in something, and that had to be invested in sufficiently large scale, right?
Those created the first industrial conglomerates, and nowadays it's a well interesting discussion. That I mean, it's nice that you're talking about this because it gives a glimpse of what we can discuss in terms of culture. So definitely follow the post of Matthew, because all of this will be covered. Very interesting. I mean, I will be following the next 90 days. I think you guys also will be commenting, and it will be interesting to see what you think about all of those topics in LinkedIn. So thank you, Matthew, for this time. It was a very nice discussion, you know, having opportunity to be on a physical location together and record it. It was great. I mean, it was one of my, first experience doing it, and I think it will be nice to redo it together.
And I think, yeah, definitely, this is worth doing again. And I think the more that we can bring together to do this jointly and to have a combination of, again, recorded content that's published, as well as live events, whether they are online or face-to-face. And I think by bringing all three of those formats together, we can achieve something pretty powerful to build a movement, that is based on a shared set of principles and values, and we can share those values while at the same time disagreeing or being slightly, you know, sort of, because that debate is important, because we need to question some of the assumptions, all right? And we need to sometimes invert established ways of thinking in order to kind of, you know, be skeptical in the right way, because that drives positive change. Anyway, thank you, Mark.
Yeah, that was nice. Thanks, and see you soon.
All right. Cheers.
Bye.
Thank you. Bye.